Uh, People many times wonder how can it be that 1 plus 2 plus 3, etc., all the natural numbers, when you sum all of them, you get minus 1 over 12. It's counterintuitive, of course. Uh, so there are many videos about this mathematics, very good videos. And this video is not about the math, it's about physics. Can we find examples in nature where 1 plus 2 plus 3, etc. is minus 1 over 12? And let me consider a few examples where we can find it in nature. So the famous, or the most famous, is the Casimir effect. So if we place two plates one next to each other, imagine that these plates don't carry any electric charge. So it's not about an attraction or some forces due to charges. It's something else. If we place just two plates one next to each other, what happens is the following. The the electromagnetic waves that can exist inside the plates are as follows. We can have either this wave or this wave, so all the possible wavelengths. Now it turns out that when we consider all these wavelengths, they all contribute to the energy of the vacuum. So the energy of this system in the vacuum, without charges, without anything, just place two plates next to each other, is proportional to the sum of all these frequencies. And so we have frequencies that are proportional to 1 over the distance between the two plates, sum over n. So the energy is roughly 1 plus 2 plus 3 plus. And this is naively a divergent series, but when we carry out the experiment, we get that. In nature, actually, it's slightly more complicated because this is a three-dimensional system and I'm giving an example of a one-dimensional system, so I'm cheating slightly, but we do measure that. And the force is dE dl, so we can measure the force. And what we see in nature is that when we carry out the experiment is that each mode is repulsive. But when we sum all the infinite contributions for all the modes, we get an attractive force, and that's measurable. And it's not only that we see that it's attractive, we can measure the magnitude, the dependence on the distance and everything, and it all confirms that when you have such a series, the sum is minus 1 over 12. So that's called the Casimir effect. It was measured long time ago, calculated and measured long time ago, and it is confirmed. And that's an example in nature where we have an example of that the sum of all the natural numbers, they give minus 1 over 12 in physics, in reality. So that's nice. Another example is the following. We have in nature particles called quarks, And when we place a quark and an antiquark next to each other, we can think about a string that gets stretched between them. Again, this string has some modes, some vibrational modes. So it has this mode, this mode, and this mode. And it's a very similar calculation to the previous calculation. If the distance between the quark and the antiquark is L, and each mode contributes to the energy of this system, then the total energy is 1 over L, 1 plus 2 plus 3, and this is minus 1 over 12, 1 over L. This energy and the force between quarks was calculated and predicted by Martin Luescher. It's CH here. And that's called the Luescher force between quarks. It's quite difficult to measure it in the lab, but one can do so-called lattice simulation, so a simulation on a computer, and confirm, at least in a numerical lattice simulation on the computer, that such a force exists between quarks. So that's an interesting example where we see again in nature that there is such a force. The number minus, or the sum of this series appears in other places. It appears in string theory, in the so-called bosonic string theory. We know that there is a certain vacuum energy that we need to get rid of. Again, the vacuum energy is proportional to the dimension of space-time minus 2 over 2 times 12. This combination appears in calculations in string theory. I will not explain exactly how. We need to cancel it to get a theory without this number. We see that if you wanted, this will be 1 for some reason, which I will not explain, then the dimension has to be 26. So the bosonic string theory, the so-called critical dimension of bosonic string theory, is indeed 26. Bosonic string theory admits 26 dimensions, and the reason there is, again, we can relate it to this series for similar reason that each mode of the bosonic string contributes to the vacuum energy, and when we carry out the sum, we get such a contribution. So overall, I try to provide 3 examples where this series 1 plus 2 plus 3 appears in physics, in physical applications. The Casimir effect, an effect that was measured in the lab, and the Luescher force between quarks, and the critical dimension of bosonic string theory.